Hello, hello. Good morning, afternoon, evening, wherever you are. I'm Josh, also known as Wolf Podlex, as you can see in my name tag. Thanks for coming to an Urbit developer call. We do these every 2 weeks on Thursdays at about 9 a.m. Pacific time. We should have plenty of these coming up, so make sure to just kind of mark your calendar for this time generally every other week. We'll definitely try and announce these going forward, but don't forget. Anyway, today we've got a pretty exciting one about third-party software distribution. This is kind of been a hot topic lately as we have more and more different applications being built within Urbit. Now, before we get into that, I want to introduce you to someone who's been working on this for a while. He's actually, been a member of our community for a long time. His name is sovmep-ripsum, or Raghu, and he's joining us right here. Hi, Raghu.
Hey, what's up?
Yeah, so I met you almost a year ago, I think.
Yeah, I think it's either 11 months or a year.
Yeah. Yeah.
Maybe the records of first contact can be found in whatever old version of the Forge group that was, if that's still around somewhere.
Yeah, that's right. It was like 4 forges ago.
Yeah.
it was a while. And we met because, I think we had both gone through the same batch of Hoon School, unbeknownst to one another. And we, at least I came out of that thinking, all right, I need to do something with these newfound Hoon skills. And that, I'd like to start a project and actually build something. And the idea I had was, because I use these every single day, and Urbit very much looked kind of like a productivity suite. It's like, okay, I need a calendar. Got to build a calendar. I think I got into the Forge. It was like, hey, anyone want to help me build a calendar? And then within 30 seconds, a minute, 2 minutes, whatever, you were like, yeah, I do.
I think that was it was very lucky on my part because, I was also like you, I was just out of food school, wanted to do something, but I didn't really know what it was yet, I'd done my, tradition to a new language, which is build the game of life. I'm sure everybody has some project they just implemented every language they learn. And that's what mine was. But after that, I was like, well, I was actually, my plan was just to go into Forge and ask if anybody needed any work done, or if something was some ongoing project. And as soon as I join, I see somebody talking about building a calendar, which was also something that I had thought about doing for a while. Mostly just due to everybody telling me that it was a really bad idea. So gotta find out for myself, right? Why everybody's like, no, don't read any of the locale code in any language. You're just thank the author and don't look at it.
Yeah. Do you feel like you found out now?
Yeah, it sucks. It's really bad. Definitely don't do it. But
you don't have to because you built one.
Yeah, that's true. To be fair to calendar writing, I think it goes pretty fine until you get to recurring events and time zones. And then, unfortunately, as I found out, a lot of the design decisions you make back when, things are nice and events are things that happen once, come around and start, looking pretty bad. Your decision to store all the events starts not looking too hot when you have an infinitely recurring event for one. So, you live and you learn.
Yeah, that's right. I think we worked on this thing, and by we, I mostly mean you. I worked on this a little bit with you for the first couple of months. And I think since then we've been talking weekly for nearly a year now. I think this was kind of like my, we sort of had a foray into the grants program, and I was very much impressed at the fact that it took all of 2 minutes to find a really high caliber person that wanted to work on this and then actually could and delivered the thing. And so that's kind of what actually even led me into the grants program and the current capacity I'm in now, was this relationship working with you, which is really cool. And throughout the course of this, the calendar, it's workable, it's live. And we had to cope with that, right?
Yeah, for sure. Fabnev Hinmer has been doing a lot of great work on the front end. I am probably the last person you'd want designing a front end. So it's really been awesome to have their help. And in terms of like features, I think we're not quite at like Google Calendar levels yet, but we're pretty close. We have invites implemented on the back end. We just need the sort of the front end to catch up to that. We have time zone support. We have recurring events. Although recurring events and invites is my current project. Once what I'm working on now is done, which I guess we'll talk about later. But yeah, I mean, if you're interested, I see the repo link is like here. Please do check it out. You can always DM me on Urbit, or we have a channel in the Forge group. If you've got any feedback, any ideas, always happy to talk.
Sweet. Yeah, it's a cool project. Definitely check it out. Now you kind of wrapped up this project around, not quite wrapped up because it's not the sort of thing that one wraps up, but it got to a point where it satisfied the constraints of the grant, was pretty much in a good done state. And about that time, we were launching a new program called scholarships. And the idea behind scholarships is that we take someone that has a good amount of experience, either with a specific domain or ideally with Urbit and Hoon, or some part of the kernel, and pair them up with an infrastructure engineer to work on a kernel space project. And this is sort of important because most of the grants that come in are more geared towards user space, towards applications and things built on top of Urbit. But there's still a lot of work to do on Urbit itself. And getting into Urbit development, actually working on the kernel, is something that really shouldn't be that hard because Urbit is so small and tight. It's a tiny code base, but it isn't immediately approachable, and so we're trying to make it more so by really pairing people up with an infrastructure engineer, Tlon, to kind of guide you through a project that needs doing. And one of the top ones at the time was a third-party software distribution that you started working on with who we have right here.
Hey.
So I'm curious to know, just what's it been like working on scholarship from both perspectives.
Yeah, I mean, it's been at least for me, when I first got into Urbit, I read some blog post or something where they were like, oh, the conceit of the system is that it's simple enough that like a single developer can like understand it. And I kind of read that and I was like, it can't really be true. Like, it's probably, I was like, it's probably easier to understand than, some sort of Unix-based system, which is what I had previously had experience working on and implementing. And after doing that, I was like, there's no way any human can possibly fit this into their mind. But when I had the opportunity to come work on it, I figured, what the heck, let's see if it actually holds up. And for the most part, I found that it's pretty true. Like the system, like Josh mentioned earlier, I think there's kind of like learning anything new. There's like hurdles, or you'll face like your first big challenge, you'll get over it, and you'll find it in the next one. And with at least with the kernel, I kind of was like, okay, here's the first hump, we get over it. Like, where's the next one? It's like, and there isn't really a next one. Once you sort of get used to the code style and sort of like some of the the more Hoon design patterns used in the kernel, I found things to be pretty straightforward to navigate. Though obviously that the first part of that would not have really been possible to navigate without Phil's help. So definitely very lucky to get to work with him on this.
Awesome.
Yeah, I mean, one need that we've had for a while and are increasingly having is just for more infrastructure engineers, people who are familiar with the levels below user space, and that's we've done a poor job of onboarding people into that because we don't have a lot of documentation in that area, and it's not the sort of thing that is as sort of straightforward to document. And things like Hoon School have been very much focused toward getting people writing user space apps, which is like a good place to start for most people. But in order to keep being able to do the things that we need to do, we need to be able to get more infrastructure engineers. And so when we look back at how our current infrastructure engineers learned this stuff and became competent at this and became familiar with it all, it's basically we all worked directly with someone who was already good at it, usually Curtis. And so we thought about basically ways of trying to duplicate that process in such a way that that we can continue to propagate that going out and scale up that process. And so it's been an experiment, and it's been going well for from my perspective, certainly. It's been great to have Raghu just jump into Clay, which has been kind of my domain for a really long time, and he can sort of immediately start doing useful stuff there, which is nice. And from my perspective, I spend an hour a week on a call with him, and maybe a little more time if he'll ask questions in the middle of the week, but not that much. And so it's in terms of being able to scale up our infrastructure capacity, I think this is a great way to do it. And I think that we should start doing more of these. I'll probably do some more, and maybe we can get some other infrastructure engineers to to play this half of the role.
Yeah, that's awesome. Well, yeah, definitely. As you can see in the banner at the bottom, shoot me a DM if you're interested in doing one of these. There's lots of work to do. So I want to segue now into kind of the stated objective of this call, which is the concept of third-party software distribution itself, which is kind of a complex thing with a lot of moving pieces. It's a pretty large problem space. What Raghu and Phil have been working on is, as I understand it, like a part of it that we call virtual desks. And before we get into the specifics of how Raghu's work works, I want to take a little bit of time to let Phil talk about the concept overall, what third-party software distribution means to Urbit, and kind of introduce us to the problem space. So I'm going to let him take that away.
Yeah. So, I mean, my guess is most people watching are already excited for third-party software distribution, or at least they want to be excited about it, and are just worried about how soon it'll happen and how well it'll happen. Urbit is obviously it's a general purpose computer. You're supposed to be able to run whatever you want on it, and in theory you can now. Basically, if you have enough know-how, you can now. But it should be the case, obviously, that anyone can. It shouldn't take that much effort to publish an app. It should be really easy to install an app. It should be safe to do that. You shouldn't be able to mess up your ship doing that. And it's just none of those things are true right now. And so in practice, Urbit is, largely you boot it, you run landscape, which is just, a suite of apps created by Tlon, that does some interesting stuff, but we don't have a calendar. We don't have a lot of things that you might want. And there have been quite a number of developers that have built great third-party apps that are just hard to in practice install and keep installed in a safe way. If you join the Forge group, it's I think middev/the Forge, the HEP Forge. You'll see people who are doing this even though it's hard, and that's great. They'll if you want to try this stuff out, especially when you want to try it on the moon or something, try to install ucal or one of these others, they can help you out. But we need something that is actually reasonable for people to use, and that that I'd be willing to put on my planet, right? I've never breached my planet, and so if I'm willing to put it on my planet, then that that tells me, okay, this is probably ready, or at least it's a lot closer than what we have now. And so in this call, we're not going to go like to the end of the line in terms of what the answer to third-party software distribution is. It hasn't, it's not set in stone yet. There's still a lot of discussion happening. Most of it in that group, especially there's a notebook called RITS where there's been some proposals about it. And so, yeah, so briefly, the current approach to third-party software distribution from a technical perspective is that you have your desk, which looks like a Git repo or whatever. And if you want to install someone else's app, you just merge it into that desk. The biggest advantage of this system is that you can look at your home desk and say, okay, this is everything that's running on my system. And so you just have this one noun, this one, file tree that describes your whole build input. And so you don't have to worry about, well, okay, this build didn't work because it didn't have an internet connection, or it didn't work because someone else changed a file on their ship without me noticing. When you need to debug a problem, you just need to look at what is the state of your own desk. But where it works very poorly is, first of all, if you want to remove an app, that's challenging because reverting merges is possible in theory, but it's awkward. The other area where it's a problem is that you don't have great isolation. If you have two apps depending on the same library at different versions, you can only use one version of that library. And if an app misbehaves in kind of any way, even on accident, there's a lot of ways that can mess up your ship. It's not even misbehaving exactly, but of just if it's not compatible with an OTA that comes with the base system update, then you could have the problem where an update comes out, it doesn't compile because of that third-party app, and then now you can't move forward until the third-party app developer updates their app. And maybe they're busy, maybe it's final season, or maybe they're just not, they're not around for now. And so you need to be able to recover from that kind of situation. Obviously, one mitigation for that is to try to avoid us doing breaking changes in at the kernel level, at the lower levels. And we're doing, we're trying to do that more and more, but there's always, but at least for quite a while, there will be some changes, there will be some breaking changes. And this also, this basic issue applies to third-party libraries that your app might be including. And so, yeah, there's not really the degree of isolation that we want. So several of the proposals that we've been talking about require a primitive that we don't currently have. Right now, the ways that you can modify a desk are you can commit and you can merge. So you can commit one file, commit a new version of a desk, or merge two desks into one. And so Raghu has been working on a new primitive called fuse, which I will let him describe how that works. But I think that there's a number of different ways that it could be applied to software distribution, and it's a useful primitive to have, anyways. All right.
All right, cool. So, all right, looks like we've got the slides up. Okay, cool. So as Phil mentioned, I've been working on something called fuse, which is essentially a new primitive to Clay, kind of in the sense that commit is a primitive and merge is a primitive. Fuse is also a primitive. But before we sort of get too into the weeds, I kind of want to define a few things, like what is a desk? there are a lot of different answers here, or a lot of different sort of facts about desks. You can say it's a piece of our file system. So it kind of looks like a Git repo. You can commit, you can merge. You've got multiple desks on a ship, and sort of like I think the biggest point, which is kind of obvious, but also very important, is that apps and user space code live on desks. It's not just kernel stuff, which, as Phil mentioned, means that we sort of have to, like having sort of breaks and incompatibility is very bad, because it doesn't just affect user space; it can affect kernel space updates. Okay, and now I want to, since this is a developer call, show a little bit of code. Don't worry, I've tried to have sort of helpful comments, and I'll let you know like what parts are not important. So this is a DOM in Clay. A DOM is your desk state. So you can see it has 4 fields in it. You can ignore the onc; it's just a cache. You can also sort of a desk is just like this sort of like highest version ID. So if you're running commit, you might see like this like number that goes up every time you commit. That's what let is. Hit is like a map of these version numbers to tacos, which are commits. We'll get into those a little bit later. And then lab is just textual labels for version numbers, not very important. And so here are some more interesting types. Taco and Yaki. These are the Clay types that sort of define what commits are. So a taco is just a commit hash. So that's sort of what was stored in the DOM. And a Yaki is the actual commit itself. So it has parents, some tacos, some data, its own hash, and also a time. So for our purposes, we can think of tacos and Yakis as interchangeable. Given a taco, you can sort of look up the Yaki, and you do that using a piece of this thing, which is the raft. So the raft is sort of your formal state for Clay. You can essentially, this is like the file system state. Like if you were going to say like Clay is like just this like blob of state, this is what it is. So I have this comment: ignore everything from mon down. We don't care about that. We can sort of see sort of 3 sort of relevant fields. This rang is sort of what I mentioned. We can sort of take a taco, like a commit hash, and look up the Yaki, the actual commit. You can do that using the rang. You can essentially think of it as a map from taco to Yaki. And then room and rung we'll talk about a little later, but just keep those words in mind. Okay, so now that we have some background on Clay, we can talk about the problem. So as Phil mentioned, we can't really conveniently distribute third-party code at the moment. Stuff like ucal, SRS. There's a chess app floating around. Users have to like manually update that code, and sort of to distribute it as it is right now. I am just sort of like cloning Git repos and like copying files over, which is not really a great workflow. 1, and 2 also sort of requires me to sort of update the code every time the app developer makes a change. And it's also not really clear what will happen if 2 apps eventually become incompatible with each other. So I don't really have great tools to sort of easily resolve that. And to sort of illustrate that, we'll dive into a little example of our current merge workflow. And before we start, I want to give a shout out to Fallon Balfus for giving these sweet graphics. I think they really illustrate the sort of point here. So thank you for that. So here is a little picture. We sort of have these, app 2, app 1, and base desks, and then we sort of have our home desk. And the sort of gray boxes represent commits on our home desk. They're numbered 1 through 9. So this is kind of what life looks like right now. We sort of like progress along with our home desk. We want to use app 1, we'll merge that in. Base gets an update, we merge that in. App 2 gets an update, we merge that in. And so on and so forth until we get to, let's say our state 9, our last state. And let's say we get to this last state and we say, okay, app 1 isn't doing it for us anymore. We want to uninstall it. How do we do that? Well, we can just revert this commit, right? Because that's the last one that has app 1, and app 1 should be gone then, right? Except not really, because we also have to revert this commit. And we have to revert this commit. So that already sucks. And on top of that, let's say that app 1 included some shared library that app 2 also used. When we revert all of these commits for app 1, the library will also be removed, and now app 2 will complain and break and say, you're missing like a dependency for me. That's not good either. So we'll sort of see solutions to all of these issues later on. We'll sort of revisit this diagram. But these are sort of like, this is sort of the problem with our current workflow. So now we get to a new primitive. So Clay supports merges. You can kind of think of as combining two commits or two Yakis into one. So what if there was a way to sort of combine several commits in one step? And that's what a send fuse is. So a fuse sort of replaces the contents of a desk with a merge of many other desks. And if any intermediate any intermediate merge fails, the whole operation aborts. You can kind of think of this as analogous to an octopus merge. There are multiple parents, etc. If you're familiar with that. Okay, and sort of to highlight how similar these two things are on the surface is I want to show the sort of two requests sent to Clay to perform each of these tasks. So send merg is obviously for a merge request, and send fuse is for a fuse request. As you can see, these two things look pretty similar. They both have a target desk that we're either merging into or fusing into. You'll see the merg request has a ship, a desk, and a case, as well as a germ. So this is sort of saying the ship, desk, and case define sort of where we're pulling our data in from, and the germ defines the merge strategy. Examples of germs are only this, only that, take this, take that. The full list is in a nice write-up in the Urbit repo if you want to take a look at the whole thing. So if we look at fuse, fuse also has a target desk, and it has this sources, this list of beak and germ. And a beak is just a triple of ship, desk, and case. So really, you can see that a merge request just has one beak and one germ, and a fuse request has many beaks and many germs. Okay. So let's go back to that workflow diagram. Here is sort of our same setup where we have our base app1, app2, and our home desk, and we're sort of trying to use app1 and app2 at the same time. And you'll notice, first of all, sort of the gray boxes still represent commits. But there is a little bit of a difference. If we actually go back here, you'll notice that all the gray boxes have like a line between them. So they're all linked. And that's because in a merge workflow, you're sort of dependent on the previous commit. It's part of your parentage and sort of relevant to determining the state you're currently in. If we go forward here, we'll notice there are no such lines between these commits. Each one is sort of unrelated to the previous commit on our home desk, which means that if we get to commit 9 and we decide that we want to remove app1, all we have to do is remove it from our list of sources and reissue a fuse request, and we'll just sort of nicely end up with this commit 10. So removing it was trivial. We didn't have to revert 3 commits. We just had to remove it from a list of sources and rerun a single fuse. If there were any common libraries sort of used by app1 and app2, since we're now sort of just combining base and app2, those libraries will obviously be included since they're included in a new commit. We're sort of merging from the app2 desk. And if we wanted to sort of re-add app1 later, it's pretty easy too. We don't have to revert all the reversions, et cetera, et cetera. We can just re-include app1 as a source, and we should be good to go, presuming that the merge succeeds. Okay, so I hope I've convinced you that this workflow is a little bit nicer. So now let's go take a look at how it's actually implemented. So do that, share. Sorry, give me 1 second here. Looks like I'm gonna have to do this. All right. So earlier I mentioned these two types, room and rung. Here's where they are. So we have room up here and rung below it. You can see they kind of have something in common. They have this map of like desk to something, right? Like you've got a dojo for a room, no relation to the terminal, by the way. This is a different thing. And we've got a read over here. So we've got those two types over here, our sort of bottom two splits. And we can see that they both contain a DOM.
Do you mind enlarging just a little bit?
Oh, sure. Here, actually, I can do that. Oh. Here. Plus, that better?
Yeah, that's better.
One more. Okay, cool. Yeah, so here we have a DOM. We have a DOM in each of these. We've got some like permission stuff, some subscribers. We don't really care about that. So the interesting thing is that the main thing is that it sort of has a DOM. So this is sort of tracking desk state, either domestic or foreign. So one of the changes that was made, we had to add this thing, this like melt. And what's a melt? It's up here. It's defined as a list of beacon germ and a map of beacon germ to a unit dome. So this is essentially tracking the state for an ongoing fuse. So when we sort of ask Clay to do a fuse, Clay records sort of the request we made over here. This is list. And also has this little spot to store responses we get. So when we sort of send a fuse request, Clay has to sort of request all of the sources that it's going to merge. And it does that. Let's take a look at, oops, not take fuse. Start fuse. So when you send a fuse request to Clay, this is the arm it calls into. It's pretty straightforward. You'll see. All we sort of are doing here is we sort of just need to make these send v requests to a bunch of other desks. And this is basically saying, hey, like I would like all the domes associated with these desks. So we just make our list of requests, and after doing some checking to see if we're already in the middle of a fuse, we sort of make our sort of generate our requests and send them out. Pretty simple. In fact, pretty actually analogous to what happens when you get a merge. So we look here, where it's pretty similar, where except for a merge, since there's only a single source, we only need to emit a single card, a single request. Whereas for a fuse, since there might be many sources, we send many requests. And so this right here, take fuse, this is sort of the meat of the fuse logic. This sort of resolves the complicated process of arbitrating all the merges, making sure we got all the data, combining everything, making sure it's nice, and then sort of finally committing it. And I say that not because I want to pat myself on the back that it's like really complicated, but really the opposite. It's really not. And this was kind of writing this arm is kind of what convinced me that Urbit's premise of the kernel being sort of simple and approachable was actually true, because all of this logic takes about 100 lines, including comments, to implement all of this functionality. I don't even know, I think if somebody said, you could implement something like this in 100 lines anywhere else, it would be kind of laughable. But it's actually true here. And I'm hoping I'll walk you through it right now. So to start, we do some, so a write is like the response type. So earlier we made those sing requests. A write is what we get back. Check to see that, there's actually some data in it, because, there's nothing stopping us from sending a fuse request for with a source that's something doesn't exist or we don't have permissions for yet, and if that happens, we would get a unit back. And then here, all we're doing is sort of updating that state we're tracking with the dome we just got back. And if all of our sources have gotten back to us, well, we can actually get into the fun stuff and start the merge here. And it's really pretty simple. So all we have here is we have our list of merges. If it's empty, we call this park function. Sort of the continuation Yaki is our sort of the state we're building up, the sort of commit we're creating out of these successive merges. And park is the arm that installs this into Clay's state. So this is, you can essentially think of park as commit. Like this is the step that says, okay, we've gotten some new state, we're gonna put it into the file system, persist it out to disk, whatever. That's what park does. So if we're out of merges, we're gonna park. If not, what we're gonna do is we call this, this merge helper using, whatever our next dome is. And if the merge fails, we can crash and complain about it and let the user know that, hey, this desk and this desk aren't compatible, and here's why. Please, either resolve those, or just get rid of one of them so you can sort of continue your fuse. And if you succeed, well, all you have to do is sort of update your commit right here. So here, essentially all we're doing is sort of advancing to the next merge. This is essentially updating the blob store with the data from the latest commit. We update our parents because we want to have, for the parents for the commit we're building all of the sources, and then we just sort of update. Our sort of continuation state is just whatever the result of the merge was. And that's really it. This is not a, I promised, less than 100 lines. I think we started on like line 2000, 2002, and we ended on like 2080. And that's it. There's really nothing else in this arm at all. That's really all it does. And it, and we've sort of gone from a list of sources to this nice, fused state. One important thing to note here is this is a mistake I actually made when I first implemented this, was actually including when I was over here was including in the parentage the original, like the previous state of the desk, which sort of is not exactly the desired behavior with regards to why, like, since fuse has a dependence on its previous state, we don't have to worry about any incompatibilities or any stuff that was going on before our latest fuse. We only care about if our sources are compatible now. All right, so let me go back, stop sharing, and switch back to my other presentation. Here we go. Okay. So lastly, I want to wrap up by talking a bit about sort of the ongoing work, the stuff I'm still working on, and sort of my final thoughts on this. So, Fuse, as described, answers how we combine several source desks, but it still doesn't really answer, how do we keep up to date with them? If we have a source that changes, we would like to, at the very least, be notified of it. Ideally, maybe it would just restart the fuse for us and then, let us know if it was incompatible. So that's actually what I'm currently working on now, a tool akin to kind of like, there's bar commit and like there's bar merge. I envision there being like a bar fuse, which is kind of a child between, bar sync and bar merge. Sync sort of tracks stuff, and merge is actually what's telling Clay to perform a merge. We just kind of need a slightly upgraded version that syncs a bunch of things and then fuses them together instead of merging. And then in terms of there is one workflow change that would come if we sort of embraced bar fuse, which is that there's nothing that's incompatible between a fuse request and sort of running like a commit yourself or a merge manually. For example, if I passed Clay a fuse move and told it to do some stuff on my sandbox desk, there's nothing stopping me from then manually committing onto my sandbox desk and then later on maybe merging some other desk into my sandbox desk. That's all kosher. However, obviously, if we were to write something like bar fuse that was automatically tracking the state, because there's no dependence on the previous commit, if it was permanently like fusing into my sandbox desk and then I made some commits, the next time a source changed, those commits I previously made would be thrown away because they're not sort of representative in the sources. Fuse will just say, oh, like you're trying to merge like the foo bar and baz desk on like this other ship. I don't know anything about any commits you made manually. So the solution to this obviously is just to to have some other desk that you're sort of committing on locally and just including that as a fuse source. But it is like a bit of a workflow change if we embrace this. So just something worth noting. Yeah. Okay. And let me just stop this. So that's all the stuff I had. I don't know if there have been any questions, but I'd be happy to take some now if there are any.
Cool. So I think we got Phil jumping back on here. A couple of questions just from my end. So you touched a little bit about at the end here about what work remains to be done. What do you? All right, I'm gonna take this. What do you see the the process of rolling this out to actually look like?
Yeah. So, well, the first thing, I think rolling it out right now. So I should be clear that like this like bar fuse thing that I've been talking about, that's like independent from Clay. Like that's not part of the kernel at all. So in fact, to roll this out, we're actually pretty close to this being able to be distributed. As of right now, like as it stands right now, the code works. The only thing that does not work is I need to sort of write some state adapters to sort of convert, since sort of like the clay state has changed. Need to write some state adapters to sort of convert a running ship that if it sort of got this, it would know what changes to make to its clay state to sort of enable the sort of fuse functionality. It's if you sort of took my sort of repo and you like made a pill from it, you could totally boot like a fake sod off of it, and that would just work. But upgrading a running ship is not something that's supported yet. But that's not due to it being hard. That's just due to me not having time for it. Since the state changes are pretty small and there's no like complicated migration. It's just slapping a bunted value in a few places, and we should be good to go. So I think definitely I don't want to hold up the world on like bar fuse being written. So my hope is that once that state adapter stuff is done, the clay changes can sort of go in as part of an OTA, and then after that, bar fuse can be like a separate PR or something. That's sort of my plan to deploy it. I don't know, Phil, you got any thoughts?
Yeah, just one terminology point that might not be immediately obvious. What you're calling bar fuse is sort of the ongoing version. It's the equivalent of like as bar merge is to bar sync. So this send fuse primitive is to what you're calling bar fuse. So it's the ongoing version of this. It probably would be clear. We'll have to come up with maybe another name for one side of that or the other to say, this is the ongoing version.
Yeah, that's for sure. Yeah, I think in my head it's all jumbled up since I've been working on it for so long. But yeah, maybe if we said like send fuse is like the single fuse, and then bar fuse is the continuous one.
Yeah, although I mean we're gonna want a command for that as well. So I mean I don't know. We'll come up with something.
We'll come up with something. The hardest part of any project, naming things. So.
Yep. Yeah. So another question. You have a full-time job, right?
I do, yes.
Yeah, and so like this is just sort of kernel development on the side.
Yeah, I mean that's what weekends are for, right? No. More seriously, I think I'm the kind of person who, if I don't have something to do, I get very bored very fast. So, I think it's really, more of it's good for me, to have, otherwise I don't know what I'd be doing with my time, but it probably would be less productive and less fun than this. So I'm glad I've got something to work on.
Yeah, sweet. So after all this work is concluded, virtual desks are emerged, they're done. What does that look like for the software developer that has something to distribute? What would be that process of getting this out to someone? And as a sidebar, maybe a follow-up question to that as well, what risks are there still that need to be solved that this doesn't address?
Yeah, I can probably speak to that. In terms of what it will look like for the developer, it's hard to say exactly. Depends on some choices that haven't been quite made yet. But in like at a high level, at least, it will be you host a desk on your ship that has this app, and other people, hopefully just install it directly from your ship. My guess is that you'll have people who will, create like well, you may have people at least in the beginning who create like a jumbo distribution where like, okay, here's a bunch of apps that you can install, and I'll make sure that they stay up to date, or that if they start falling behind or whatever, that like you can still advance your kernel or something. Over time, of course, that should be less necessary as we improve isolation and that sort of thing. But even now, if someone's willing to put in the almost administrative work of and the like bug fixing work of just like, let's get these, like make sure these apps still work as OTAs go by, you could have a sort of separate distribution that has all these apps. But yeah, what it should be like, one of the biggest differences between this and normal software distribution on Earth is that, you know, with something like NPM or the Apple Store or whatever, App Store, I guess. There's one place you download stuff from generally, and that would not be the case for us. It would be generally you download it from the developer. In terms of risks, for quite some time, there's going to be like running someone else's code on your machine is always going to be risky. At some point, you know, we should get to the level of sandboxing that something like the App Store has, where, yeah, you shouldn't install a malicious app, but it's not like it's going to be that big of a deal. You just kind of have to ask for permissions to do anything that's, you know, that's risky, other than maybe just use a lot of your RAM. And so we want to get to that point, but it's going to take quite a while. And from a process standpoint, the way to get to that point, at least the only way that we've made progress in the past, is basically to, you know, to get people using it, and that forces us to make it more stable, to make it more reliable, and you know, eventually more secure. So definitely don't just install random people's stuff, but people are pretty good at evaluating whether someone is, at least in a community of our size right now, people are pretty good at evaluating what apps are, you know, what people are trustworthy, and and so that would protect from, you know, and if you don't know, just ask around and you'll probably get a good idea. If that will protect from sort of malicious by the app author. There may of course be accidental security holes in apps, but there's almost certainly accidental security holes in landscape right now. And so, you know, because it looks so polished, or at least as polished as it does, it's tempting to think, it's easy to fall into a mindset of okay, this, you know, because it's more reliable and more stable, it's also more secure. But we really haven't gone through the effort of making even landscape secure. And so if someone's really trying to get into your stuff, you know, they probably can. And so that's, you know, going to be true of third-party apps as well, at least for a while. But hopefully we can make progress in that soon.
So we've had a couple questions come in. One from Little Wolfer here. So the way I can test this with something like SRRS right now, I assume meaning virtual desks.
Yeah. So it would be a little bit involved. So okay. So on my, I think my GitHub was linked earlier. For when ucal was being displayed, I have a pin of the Urbit repo there where I've been working. There's a branch for that. So you know, you would have to sort of clone that. Then you would have to you know, make a pill and then boot a fake sod off of that pill. But once you have some ships sort of booted through that, yes, it would be, you know, if you put SRS into one of them, and then sort of you could totally just, you know, send fuse requests around, and that should work. Yeah, and you know, if you have any questions, you know, hit me up on Urbit or something. I'm happy to help out.
He'll be the guinea pig, so it works.
Good.
Related to that, what is this software that you speak of? Yeah, SRRS. If you don't know, this is an app that Little Wolfer's made. You should definitely check it out.
Yes, space repetition. Actually, I don't remember what it stands for, but it's a space repetition.
I think it's space repetition. Yeah. No, really.
It's a repetition space. Yeah.
Yeah.
Another question. Right now,
right. So he's saying that if an app doesn't compile when an OTA happens, that prevents the OTA from going through. So that so Fuse does not change that. We do have, but it'll well, yeah. So now that we have the ability to either remove or suspend an app, so fade or doze an app, it will be like we now have sort of an answer to what should happen. When an OTA happens, you should be able to specify that, hey, this app, if it doesn't compile, suspend it instead of crashing the event. And so that work has not been done yet, in part because it just doesn't matter that much if without more of the software distribution story being answered. But it's sort of starting to matter more as we build things like Fuse and work in that direction. So yeah, that would be a great piece of work to do, for someone who's familiar with or wants to learn about the our error handling mechanisms.
Cool.
And here I thought the error handling mechanism was just crash.
Well, it is most of the time, but
Yeah.
sometimes you want to say, actually, I want to crash only in these circumstances, and I want to handle that crash in other circumstances. And that's something that we are capable of doing. That's a lot of well, in the last couple of years, basically, we've made a lot of progress in being able to do that well. For the longest time, it was like, well, yeah, try and crash, but like if you don't want it to go all the way away, then you just have to try and catch it all in band and use a lot of sigs and hope that you didn't accidentally assert somewhere you didn't mean to. And if it does crash, your subscription is just going to be stuck. Oh well. And so we have like answers to that. Importantly, we have them in theory, and we also have implemented them in a lot of places. But like, so we know the patterns for how to write this kind of error handling, and we use it extensively throughout the system. And so we just need to apply it here.
So another question. Sounds like a next step would be a reputation capability step system.
Well, yeah, I mean, there already are permissions for desks, if that's what you mean. But I think I remember maybe it's in RITs actually. Somebody was talking about like a permission system for veins, which I think is like super necessary. Like kind of like what Phil mentioned earlier about the App Store. If you like install some app and it starts asking like, can I go read jail? You might think twice about using said app. But I don't know. Maybe Phil can speak to like where the work is, like what the state of that is.
Yeah, the permissions that we have for Clay are to allow people to read or not read from a desk on someone else's ship, to read the files there. But you also want to be able to have within your ship, you should be able to say, I installed some third-party chatbot. It can talk to the chat app. It can't talk to, my dojo or my hood, or it can't submit it can't change my file system. It can't upgrade my kernel, right? And so yeah, a capability system there is critical to doing this in a secure way. One of the things about Urbit is, if our tagline is kind of simple, durable, and yours, it's hard to get yours without sort of a high level of security that we're really not at yet. But at least we can get durable before that, as long as, or at least reasonably durable. And so we can keep going forward without it being terribly secure. But that certainly puts a limit on the kinds of things you can do on Urbit and on our growth, and just in terms of its general usefulness. Reputation is another one that it's an interesting one to think about, and it's fun to think about the ways that you could do this sort of mechanically. to try and draw on, I don't know, the wisdom of the crowds or something. Like reputation is something that exists in any system like this, and it's just a matter of how formalized it is. With something like Uber, it's quite formalized in that you basically just trust the star rating, and it actually, like, in fact, you don't even really see it. It's that Uber decides who's what's their minimum star rating, more or less, that they'll allow. In a smallish community, you have a reputation system that's based on people just interacting with each other, and like humans are very good at inferring who to trust in that situation. They're definitely not perfect, but they're better than any mechanical system really can be, or at least that I've seen, when you're at that scale. As the scale goes up, you stop being able to tell who's trustworthy and who's not. And like, so the kind of natural human way of evaluating reputation gets harder. And the mechanical idea of reputation gets easier because you have more data from more people. And so we'll need to lean on that, at some point in the future.
Cool. Well, I think that is a wrap for the questions we had. Now is probably a good time to transition into the more free-form hangout that we like to do at the end, where you can come in and join us on a meeting where we can just hang out and talk and shoot shit. So with that, I'm going to actually go ahead and paste the link to this thing in the chat, which is easier to find. Let's see here. Oh, hang on one sec. We still have another question here. So stuck in Hoon School, wanting to get some help. Yeah, the Forge is a great place. The development channel and Urbit community is also good, but the Forge is, yeah, I'd say the Forge is the place to go. Hooniverse is another good one. Someone could post the full group name to that in here. That would be great. People are very friendly. Hopefully that comes through. You can feel free to shoot me a DM if you want to get more involved in something. If you're stuck, you can also reach out to Phil, to Raghu. There's lots and lots and lots of help available should you start asking questions. Scholarships, yeah, some Hoon is sort of expected there. This is where you're going to be working with an infrastructure engineer, and it's best if the language fundamentals are already kind of down. A good way to get started on a scholarship is to kind of take the path that Raghu did, and work on something first. Build a project, and get your chops with the language down, and the basics of the system. Now, I don't know that you have to go that way. It may be possible to dig right into infrastructure development. This is enough of a green field to where we don't really know what all of the paths are, and yours may vary. If you want to talk to us some more, jump on this link right here, where we're going to go in a moment. So I think with that, we can go ahead and call this a wrap for developer call. This has been great. Thanks, Raghu. Thanks, Phil, for doing this.
Yeah, thanks, Josh.
Yeah, it was awesome. Thanks for having us.
Yeah, this went really well. Also, thank you to StreamYard, which is the software we're using to do this. This is certainly something we're going to be using more of. Production quality is quite high, so I'm feeling very satisfied. Anyway, also mark your calendars. 12 days from now, we're going to be launching another product. That's the Bitcoin wallet. And speaking of reputation and capability systems, this is one of those applications that would benefit from such a thing. For now, we're having to, especially if there was anything that really needed to have a strong security model, it's this. We don't have that strong security model yet, so we are going to be managing the distribution of that through the Urbit repository the same way Landscape does, which is kind of the next best thing that we could do. Also, exactly 2 weeks from now, well, 13 days and 23 hours from now, we're going to be doing another developer call where Edward Amsden is going to be demoing the WebRTC work that he's been doing. That's a pretty exciting one. There's a lot of stuff you can do with WebRTC, like video calls, video and audio, drawing applications, direct peer-to-peer data over the WebRTC protocol, which is quite useful. So tune in for that, and we'll see you there, and we'll see you on this Google Meet momentarily. Thanks, everyone.
Nice.